Okay, so this is for ECE 4305 lab for the fall of 2021. This is lab 8, the potentiometer controlled chasing LEDs. So here we could see my Nexys A7 board, and we're interfacing with the JX-ADC interface right here. And this is controlled by the X-ADC core that we have in our microblaze system. So we could see here that we have a few jumper cables shorting the 8010, 82, and 8011 channels. And this is just so that way we don't get noise in these channels. Just for good practice, we're not using them, so it doesn't really matter. But here we have our circuit, so we can see the schematic right here. So we have VCC going to R1, which is this resistor right here, which is a 22K, and then that goes down to a 10K resistor or potentiometer, and we can see that the yellow wire right here is running to 83P, as seen in the schematic right here, and then the ground side of this potentiometer, we can see by this wire, is connected to this white wire, which is it's hard to see, but it's this white wire right here. We can see that it's in the ground terminal, and then that comes back down to 83N. Okay, so now that we have our circuit, we can also see that these ones are shorted right here. We're gonna go to Vitis, and we're going to program our FPGA, and we could see on screen right here too that we have our putty terminal, so that way we could see the changing speeds, as well as the ADC input. And then this speed is just reference to the millisecond delay from which the LED jumps from one LED to another. We can see that also our on-off switch right here works too. So when this is pulled high, we're not doing anything. We're stuck at the 0 LED, but as soon as it goes low, we get the chasing LED effect. And then we can see that when we twist our potentiometer a little bit, that we're getting different values in our putty terminal right here via UART. We could see this. We could see that the ADC input is increasing in value. All right, we can think of this as a percentage, and then this is the algebra that we did to modify this. And we could see that with this little bit of code right here that we're reading in the ADC value, and then based on that, just from the previous lab, I did 100 milliseconds to 857 milliseconds with a 32 step size. And the step size is 25, but there's 32 different possible values from 0 to 31. And then we just start at 100 and then increment obviously all the way up to 875. So we can see right here, if I pull the potentiometer as high as we can go, we can see right here that the little arrow is pointing this way. That we have 850 millisecond delay, and we can see that the LEDs are actually indeed slowing down right here. So now that we have the terminal all the way, let me modify the pot right here, and you can see that it's going to start getting faster because I'm decreasing the resistance. And we can also see that RX is writing because we're getting new delay values. So if I put it lower and lower, currently we're at 100 right now, we can see that on our terminal. So yeah, this lab does work. And that concludes the lab demo.